video is going to focus on using polynomials in the real world. For this, For this, we want to use Desmos. It doesn't matter if you have a graphing calculator or not, you want to use Desmos for this. So the reason we want to use Desmos is because it's going to help us by giving us some exact points, and we're not going to have to look for them like we normally would. So what we're going to do here is we're going to type each of these things in, each equation in, and we're going to use the words in the problem to help us figure out what we're looking for. So anytime you're given an equation, you need to type it into your calculator. Then we're going to go through and read this and underline all the important pieces. Dick's Sporting Goods found that its monthly profit is P, is given by the function P of x equals negative 10x squared plus 120x minus 150, where x is the selling price for each set of golf clubs. Estimate the maximum price per unit of golf clubs that the company should charge to maximize their profit. So whenever we see the word maximize, we want to find the biggest piece of that graph. We want to find the maximum. So I'm going to take my phone here and I'm going to go over to Desmos. So you can get this as a calculator app, or you can get it pulled up on your computer screen. And so I'm just going to type in my equation. So negative 10x squared plus 120x minus 150. When I type that in, you guys can sort of see it on my screen. There are these itty bitty circles at the top and on the axis here. Since we're looking for the maximum, we're going to tap on the little dot that's up at the top. And sometimes you may mistap. A lot of you guys, when you first pull this up, you may be zoomed in really far. You can just use your fingers or your mouse to zoom in and out, because we want to look at the maximum. Click on your graph, because sometimes if you click off of it, the dots will disappear, but click on it and then try and tap that dot at the top. So we've been told here that the max, the point there, is 6, 210. Now, this is the coordinate point. We want to put this into context though. So it asks you to estimate the maximum price per unit of golf clubs that the company should charge to maximize their profit. So it doesn't want to know what the maximum profit is, but it's asking about the price per unit. So in this case, it is $6 per unit. So we write out the entire coordinate, but we just pick the piece that we need. So sometimes you'll need the x, sometimes you'll need the y. Just use the context of the problem to help you decide which. Next, number 2 is very, very similar, so I want you guys to try that one on your own. You'll do the exact same thing. We're going to read it together so I can help you underline those key points, but I am going to have you guys try this one on your own. So TJ Maxx found that its profit is given by the function P of x. If you see P, it's probably profit, where x is the selling price for each pair of jeans. It has you estimate the maximum price per pair that the company should charge to maximize their profit. So we're looking for the maximum. We'll do the exact same thing as we did in number 1. For number 3 here, this one is a little bit different. So it gives us a lot of information. A baseball is hit from a height of 5 feet at a rate of 10 feet per second. Use the function h of negative 16t squared plus 10t plus 5 to find out how long it will take for the ball to hit the ground. So we want to know how long it will take for the ball to hit the ground. Based on what information we have in the problem and what our variables are, h, that's going to be our height. And t, it's almost always going to be your time, And in this time, we see our height is measured in feet, and our time is measured in seconds. So that's important. That's why this first sentence was included, because otherwise it doesn't really help us other than establishing what the variables mean and what our units are. Now, we want to know how long it will take for the ball to hit the ground. So if something's on the ground, that means that our height should be 0. So if it tells you to look for something on the ground, instead of looking for the highest point, we're going to look at where our height is 0. So I'm going to take my phone and I'm going to type in that equation. So -16, and for the t, you can just put x in there. You could do t if you wanted. It's whatever you like. X squared plus 10x plus 5. Alright, as you can see, this is a very different type of graph from our first one, so I've got to zoom in a little bit. And we want to know where it hits the ground. Anytime we do a polynomial problem like this, the ground is represented by the x-axis. That's the ground. Everything below it, that's like underneath. So I'm going to tap on that graph, and as you guys can see here, I know it's a little hard to see, but the dot that we saw in the maximum, there are also dots right here where it crosses the x-axis. That's because those are critical points that we tend to solve for a lot. Whenever we are working with real life examples, we don't worry about what's on the negative side of the graph, because in the real world, negatives only occur in a bank account. We only want to know about this root right here. So right here, I'm going to click on that dot, and it gave me the coordinate point, 0.953, 0. Our height, that was our y variable. And we know that because that's what our equation was equal to. So our height's 0 at this point, and it took 0.953 seconds for it to hit the ground. So if it says maximum, we're going to press on the top dot. If it says hits the ground, we're going to look at those dots on the x-axis. Remember, we never want to use a negative x. We just want to focus on the positives. Sometimes you'll only have one value like we do here. Sometimes you may have more. All right. As we come over here, I want you guys to try out number 4 on your own. You just type the equation into Desmos. Our monthly profit is P. X is the selling price. And we want to know the values of X that will produce 0 profit. You're going to have 2 answers here. And since we're looking for 0 profit, we're going to be looking at those dots on the x-axis. I want you guys to try 5 and 6 on your own as well. So we're going to walk through the information here just so you guys understand what it's looking for. Jordan Spieth hits a 7-iron onto the green. Use the function h equals -16t squared plus 80t to represent the flight of the ball. How long will it take for the ball to reach its maximum height? Anytime you see the words how long, we're going to be looking for the x, or in this case, the t. 6 is a little different. Russell Wilson throws a football down the field using the function h equals -16t squared plus 40t plus 6. Find the maximum height of the ball. So in this case, we're going to be looking for the y value, or in this case, what we would call the h value. And the last question down here we're going to do together. 7 gives us a function. The function v of t equals 0.173t plus 0.152t squared minus 0.035t cubed, where t is the time in seconds, t, time in seconds, describes the volume of air in liters in the human lungs during a respiratory cycle. About how long does a regular respiratory cycle last? So we want to know how long a cycle lasts. So we're going to be worrying about the x values here. I'm going to go ahead and take my phone. And I'm going to go ahead and start by typing in that equation. So I have 0.173x plus 0.152x squared minus 0.035x. And in this case, if you're trying to cube something, you're going to use the AB button instead of the A squared button, so you can change your exponent. All right, from there, we're going to zoom in real quick. So we're going to zoom to where we can see the positive side of our graph. When we tap on that graph, first of all, we see that it has an it has a root or an x-intercept at 0, 0. So this baby starts at 0, 0. And we don't care about the maximum, but we care about how long it lasts. So we come over here to where it ends. And we see it ends at 5.279, 0. Remember, we don't look at the negatives because negatives are just not applicable in real life. The only time negatives happen is in bank accounts, but otherwise you can't have a negative number of golf clubs. You can't have a negative amount of pi. You can have 0 or you can have a positive amount, but negatives just don't realistically happen in the world. So now that I have these 2 points, I'm able to figure out how long a respiratory cycle lasts. So it starts at 0, and from where it starts to where it finishes and gets back to that x-axis, it takes 5.279 seconds. And I got that seconds because it says the time is in seconds. Sometimes you guys will have more than 2 points that you have to look at. Try out the starred problems on your own and let me know if you have any questions.